What's up? It's your boy Amateur Pro Home Chef Nathanael Levinson. Today we're going to be talking about citric acid. So citric acid is an acid. It's a weak acid. Now, weak acid doesn't mean it won't hurt you. So acetic acid is a weak acid. That's the one in vinegar. But if you have 100% acetic acid, it will melt your skin off. So weak and strong acids has to do with dissociation and a lot more complicated stuff that we're not going to talk about it. So, but when someone says weak acid, don't think it means it won't hurt you, because it will. But citric acid is a weak acid. It's diprotic. You can take that proton or both. So it's happy to do both. So it's a diprotic acid because it can donate 2 protons. And it is found primarily in citrus fruits. Now, what's interesting about citric acid, there's 2 acids mainly we find in citrus fruits. There's citric acid and there's ascorbic acid or vitamin C, which we'll talk about on another day. What's fun about citric acid is that it's sour, but provides no flavor at all. So you can actually purchase crystallized citric acid, pure solid citric acid, and you can sour things with it. And I guarantee you've encountered this. If you've eaten Sour Patch Kids or Trolley Bright Crawlers, those are made sour with citric acid. You can use it at home in drinks and in other things to add a little bit of sourness. Well, the other thing that's interesting about citric acid is that it is involved in a very important biological function called the Krebs cycle. The Krebs cycle is basically how we process things using oxygen. So what happens is when you consume anything, any carbohydrate, it gets broken down eventually into glucose. Glucose goes through a 10-step process called glycolysis, which converts it to pyruvate. And I'm going to yada yada over that. Maybe we'll talk about that a different time. But it turns it into pyruvate. And that takes no oxygen, but it doesn't produce a lot of energy. So what happens is the pyruvate gets thrown into what is called the citric acid cycle. And it starts with citrate. And then it cycles through a whole bunch of steps where citrate has things attached to it, and then it goes around in a loop and a loop and a loop, and you never lose the citrate, but you basically hook on a pyruvate, and eventually you pump in, at some point you pump in oxygen, and at some point you get out carbon dioxide. And this is how respiration works. The Krebs cycle, the citric acid cycle, uses oxygen and releases carbon dioxide in order to provide you with energy. And that's why citric acid is so important. Until next time, I'm your boy, Amateur Pro Home Chef Nathanael Levinson. Citric acid.